Okay, so we had a quiz over Chapter 9, and we did some volume stuff, some ratio stuff, so we can check these ones out. So, the first one we had is we had a lightsaber, Kylo Ren's lightsaber, Star Wars test for Star Wars Day, is 3 similar cylinders. We got 1, 2, 3 cylinders. Okay, the 2 small ones are congruent, so they're the same. One of the smaller cylinders has a radius of 3. Alright, so we know that this has a radius of 3. Let's say R. And the larger cylinder has a radius of 12. We need to find the ratio of the volumes. So that ratio of the volumes, that means I need to know R cubed, my ratio cubed. So I can find my linear scale factor to get to my volume scale factor. So to get my linear scale factor, I'll do 12 divided by 3. So my linear scale factor is 4, or 4 to 1. And to get R cubed, so that's my linear scale factor, to get to volume I need to cube this. So volume is equal to 4 cubed. So my volume scale factor is 64. And since there's 3 of them, we know this is 64 to 1. So 64 to 1 to 1. And if you just put down 64 to get the R cubed scale factor, or you did 64 to just 64 to 1, those were both okay, so those worked out pretty well. For the second one, we're given the surface area of the large cylinder. So that surface area is 792 pi. So we should be a little bit suspicious that we got a pi right there. Typically those will kind of bow out of the problem. We also have a radius of 12. We want to find the height of the cylinder. Well, since we know the surface area, I can draw a nice net. So we know the radius is 12. So that means we can get the whole circumference. We don't know the height, because that's what we're trying to find. So to get our circumference, we'll do 2 pi r. So 2 times pi times 12, that makes that 24 pi. So now we need to find the area of each of the pieces. So we got the circumference here is 24 pi. So we know that the area of the rectangle piece here is 24 pi times the height h. So we just need the area of the 2 circle pieces, but since we have the radius, we know that area is pi r squared, or the area is 144 pi. So we've got 2 of these and 1 of these, so we can rewrite the whole equation as the total surface area, 792 pi, is equal to 2 times 144 pi plus 24 pi h. So we can do a little simplifying. We can kind of combine these ones. 2 times 144 is 288. I think I'm going to go on to the space over here, because then I can subtract my 288 and get 504. So I'm going to do minus 288 pi. I'm going to rewrite it over here. So I'm going to end up with 504 pi equals 24 pi h. Then I'm going to divide both sides by 24 pi. So doing that, we get 21 equals h. Alright, so that's how we can find out what the height of this thing was. Cool. Alright, next question. Question 2. So we've got 2 volumes given. So the Death Star, the original one from way back in episode 4, is 500 pi. Starkiller Base from the new movies got pretty giant volume, 288 million pi.
They're spheres, that's okay, so we just know that all spheres are going to be similar, so we know that these things are similar. We need to find the ratio of the surface areas. Well, we can find the ratio of the volumes, so that's r cubed, and that's going to be, we're just going to divide these two. So that's 288, 1, 2, 3, 1, 2, 3, all over 562, 500. I know I can take care of a couple of those. Then I'm going to divide them. When I divide them, I get r cubed equals 512. But I don't want the ratio of the volumes. I need to get to surface area. So I'm going to find r. So I'm going to take the cube root of both sides. So I get r is equal to 8. And then for surface area, well, I know that that's r squared. So I'll do r squared equals, well, 8 squared is 64. For the next one, we had to find the surface area of the triangle here, triangular prism. So we need to find the areas of each of the pieces. Well, the squares are kind of easy. They're going to be base times height, so we get 3 100ths. And the triangles are a little bit trickier. So we know we've got equilateral triangles. So we've done a lot of these where we drop the altitude down to find the area. We know that this length is now 5. We know that this angle is 60. And we need to get the height right there. So we're going to need to use one of our trig tricks, or we could use our 30, 60, 90 triangle. Pretty nice that it's 30 degrees across from the 5. We can just kind of make this 5 root 3. And again, that's from the 30, 60, 90 triangle relationship. And then area of the triangle is 1/2 the base times the height. So we know the base is 5, the height is 5 square root of 3. So we can do that, and we can get 5 times 5 is 25. Put the base down. Well, let's do the base of the whole thing. So we'll make it all an even 10. 10 times 5 root 3, which would be 25 root 3. So we know each of the triangles is 25 root 3. So when I want to add them all up, I've got 100, 200, 300, and 25, and another 25 is 50, square root of 3. Now if you did a decimal approximation, that turned out to be about 386.6. Alright, the next thing we had to do is find the volume of this. So we're going to use our formula. Volume is the area of the base times the height. And here our base shape is going to be this triangle. So we got that triangular prism, so we need to have the area of the base, which is the area of the triangle. 25 root 3 times the height. And we know that this line is the same as this one, so that's 10. So we get 250 root 3. And if you kind of approximated that, that's about 433. So that's what we get for our volume. Next one we had was a little bit of review from the last chapter. We had to find the internal angle, we had to find how many sides it had. So I'm going to do the 180 minus to get the external angle. So when I do that, I get 14.4 degrees for an external angle. Now I did that because I know the external angle formula is 360 over n equals the degrees of the external over 1. So I can set up a nice little ratio and just kind of cross multiply, because I've got 360 equals 14.4n. Divide both sides by 14.4. And we get n equals 25. On the back, we had to kind of get the views for this thing. So we had a 3D isometric, and we had to kind of get each of the different views. The top view would be if you were looking from a bird's eye perspective. So that would be that, and that. And we've done pretty good with this. Most people on the test got this one right, so we did a really good job with these. The front view, also we would kind of say, all right, if I'm looking at it from the front, I've got 1, 2, 3 blocks high. I've got 2 blocks high. And then I've got 1 block high. If I was looking at it from the right, I've got 1 block high, 2 blocks high, and 3 blocks high. The map plan is just the number of cubes that we have in each square. So this one we've got 1 cube, 2 cubes, 3 cubes, 2 cubes, 1 cube, 1 cube, and either 0 or blank. We assume that this is not a floating box, so we kind of assume that it's on top of 2 boxes. To get the volume, we need to add all these up. So 3 plus 2 plus 1, plus 2 plus 0 plus 1, plus 1 plus 0 plus 0, which is 10 units cubed. The next one, we wanted to draw a net for a solid with these dimensions. So a little bit of a hint, we had these 3 different things. We had to kind of think, well, what kind of nets only have 3 objects? And also it would include some kind of circle for pi. And it turns out it's going to be the cylinder. So we want to draw a net for a cylinder. So if you added them all up and then you went ahead and found the square root of that and made a nice little cube out of it, that's okay. That's fine too. But the way it's set up, it's kind of set up to be 16 pi, 16 pi, and then 56 pi. So knowing that, we got to find our radii. So if we know that the area is 16 pi, but area equals r squared, equals pi r squared. So we'll have pi r squared equals 16 pi, or r squared equals 16, so that means that r equals 4, because here we had to label any radii or sides. So we know that the radii is 4. So the last thing we'd have to do then is find out, well, I want to find my height. So I got to get my length. That's found by the circumference. We know that circumference equals 2 pi r. So circumference equals 8 pi. If the whole area is 56 pi, the area of the box equals the length times the width. So, 56 pi equals 8 pi times the width. So we can divide both sides by 8 pi. We get 7 equals the width. The last thing we needed to do was create a map plan for a rectangular prism with a volume of 6912. The simplest solution is sometimes one that seems like a trick. It's 6912. So I just made a giant tower, 1 block, 6912 high. Now you could come up with any sort of map plan. Another common answer would be if you split it up and made one of the map plans that looked like this. So if you split it up into 3, each box is going to have 768 inside. So we would just have a bunch of 768s. So that was probably the other common answer that I saw. So as long as it was a rectangular prism, though, some people did them a little bit bigger, that's okay. It did have to be a prism, so you wanted it to be the same dimensions. It didn't take off too much if you didn't make it a prism, if you made it something different, just a strange shape like that.